Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome, my dear students, to the unit number 5 in geometry section. In the third preparatory stage, lesson number 4 talk about the cyclic quadrilateral. First, you must know the definition of cyclic quadrilateral. It's a quadrilateral whose 4 vertices belong to one circle. It's what? Quadrilateral whose 4 vertices belong to one circle. This is the definition. We will study converse of theorem 2. Talk about if two angles subtended by the same base. Two angles, okay, as angle C and D, subtended by the same base. The base is AB. And on the same side of it, they are line up of it on one side. Have the same measure, that means measure angle C equal measure angle D, okay? If that satisfies, then their vertices, the vertices A, B, C, and D are on an arc, okay, of a circle. And the base is a chord of it. AB is a chord of this circle, okay? That means if or since measure angle C equal measure angle D, measure angle C without circle. If measure C equal measure D, okay, then ABCD is called cyclic quadrilateral, okay? Hence, there are some special cyclic quadrilaterals, okay? There are three shapes. Number 1, the rectangle. Number 2, square. Number 3, the isosceles trapezium. Okay, rectangle, square, and the isosceles trapezium. All of these are cyclic quadrilateral. We will study example 1. ABCD is a quadrilateral in the opposite figure, okay? Its diagonals intersect at E. Diagonals intersect at the point E. Prove that ABCD is a cyclic quadrilateral, okay? And also find the value of X. We know the measures of 4 angles. This angle, this angle, this angle, and this angle. Okay. To prove that ABCD is a cyclic quadrilateral, okay, in the previous theorem, we must get 2 angles on one base and they are equal. 2 angles on one base of the 4. Okay. If we consider that AB is the base, where is the opposite angle? Yes, it's D, 48. AB, where is the opposite angle? It's angle C, this angle. But it's not exists. But when you see this is a triangle, 32, this is a measure of this angle, 100, the measure of this angle, we can get this angle because the measures of 3 angles of a triangle is 180. Then we can get this measure. If this measure, okay, it lies on the base BA and equal this measure of this angle equal the measure of that angle, then the shape is a cyclic quadrilateral. Let's get by proof. The proof, since CBE is a triangle, therefore measure angle, this angle is BCE equals 180 minus 32 plus 100. When you compute it, it will be 48 degree. And since the measure of angle BCE equal the measure of angle ADB, okay, ADB 48 also, okay, and they lie on the base BA. They are on one base, okay, and of one side of it, and of one side of it. That means what? That means ABCD is a cyclic quadrilateral. This is number 1. Number 2, we want to get the value of x. Where is the value of x? X is the measure of angle DCA. When ABCD becomes a circle, becomes cyclic quadrilateral, then any two angles on one base and of one side of it are equal. Then this angle, okay, x, opposite to the base DA. Where is the angle opposite to the same base? Yes, it's DBA. DBA equals 64. Then also x equal 64, because the two angles, this and this, they lie on one base DA. Okay, and since ABCD is a cyclic quadrilateral, therefore measure angle DCA equal measure angle DBA. And note, they have the common base DA. Therefore, this angle equal 64 degree, and this is the value of x equal 64 degree. This is example number 1. Example 2. ABCD is a quadrilateral. Inscribe it in a circle. Inscribe it in a circle means the four vertices lie on a circle. That means ABCD is a cyclic quadrilateral. This sentence, okay, means that ABCD is cyclic quadrilateral. Okay, its diagonals intersect at E. The intersection point of its diagonals is E. And XY, okay, parallel to BC, Prove that AXYD is a cyclic quadrilateral. Prove that what? AXYD is a cyclic quadrilateral. And also prove that measure angle BAX, this angle, we want to prove that measure angle BAX equal CDY. We want to prove this. Okay. First, how can we prove this shape AX? YD is a cyclic quadrilateral. We should get two angles on one base and equal. Two angles on one base and equal. Okay. But in the first sentence, we have a cyclic quadrilateral. Then any two angles on one base and of one side of it are equal in measure. Then we can say that if we name this angle 1 and this angle number 2, number 1, this angle, okay, it's inscribed it's inscribed angle, and also DBC inscribed angle. They have the common arc subtended by the same arc. Then measure angle 1 and 2 are equal. And also, when we name number 3, this angle 3 equal measure angle number 2, because the two sides here are parallel. Then the two angles 2 and 3 are corresponding angles of F letter. As you see, this is number 2 and this is number 3, because of the two lines are parallel. When 1 equal 2 and 2 equal 3, then 1 equal 3. 1 and 3 lie on one base inside AXYD. Inside AXYD. Number 1, DAY. Number 3, DXY. They are equal? Yes. And have a common base? Yes. Then this shape AXYD is a cyclic quadrilateral. Let's write this part. Proof. Since measure angle number 1 equal measure angle number 2. Because of what? They are inscribed angles. Only? No, they are subtended by the same arc. Which arc? DC. The arc DC. And also, since XY is parallel to BC, therefore measure angle number 2 equal measure angle number 3. This is the deduction number 1, the deduction number 2. From 1 and 2, we can say that measure angle number 1 equal measure angle number 3. Measure 1 and 3 lie on one base. Which base? It's dy. It's what? dy, as you see. dy, and of one side of it. That means this shape AXYD is a cyclic quadrilateral. Okay? Let's think in this proof. Measure angle BAX, we want to prove it, equal measure angle CDY. Okay? Let's think. Number 4, number 5. 4 and 5, two angles. Okay? Inside the quadrilateral AXYD, or the cyclic quadrilateral, as we prove. Then they are equal. Number 4 equal 5. And also all of angle, all of angle D. Okay, it's inscribed CDB, angle D, CDB. And angle A, all of it, CAB, inscribed also. And they are subtended by the same arc, CB. Then the two angles are equal in measure. When we subtract D, okay, or when we subtract 4 from D, it will be this angle. When we subtract all of angle A minus 5, it will be this angle. Therefore, this angle equal this angle. That means measure angle BAX equal measure angle CDY. Let's write it. Since measure angle CDB equal measure angle CAB. Okay, because of what? Inscribed and subtended by the same arc. Which arc? We said that CB. And also since AXYD is a cyclic quadrilateral. Therefore, measure angle YDX equal measure angle YAX. This number 3, number 4, by subtraction or by subtracting 4 from 3. Okay, therefore measure angle, this angle CDY equal measure angle BAX. And finally we have finished example 2 and finished lesson number 5 is the cyclic quadrilateral. Thank you for listening and watching me. With you, Mr. Mahmoud Askar. We will complete the lesson after that, inshallah. Thank you.